All right, so we continue on. This is covering exercise 9A-B-C. D I'll leave till next week, and then E I'll focus on chain rule and all the other rules, which covers F, G, H, I on Friday. So D I'll just leave a bit later to do. D is gradient graphs if you're interested. Okay, you can have a look at that too if you want. All right, now let's summarize what you've learned so far. Last lesson we talked about power rule. We talked about first principles and what was the purpose of first principles. To summarize, purpose of the first principles was to find the gradient of a tangent line, but specifically at one point. That was the key thing. All right. First principles relied on the fact that to find gradient, it's y2 minus y1 over x2 minus x1. That's your rise over run. Yeah. Then we converted rise over run, average rate of change, to first principles formula, but there is also another one, which the one that at the start of year chapter 2, some students had forgotten about it. Tan of theta is also equal to the rate of change. Why? Because tan of theta is also equal to sine theta over cos theta. And if you remembered, sine represents y, cos represents x, which is actually rise over run. Okay, so same thing again. The tan of an angle actually gives you the gradient of a specific line at a specific point. Okay, here's an example. Example 4, you've got a curve of 3x squared minus 5x plus 1. Find the gradient of the tangent line that touches the curve at x equals 2. All right, so you want to find the gradient. Okay, gradient of a tangent line at x equals 2. So let's visualize it roughly. I don't know what the graph looks like, but let's just say it looks like that. It's a positive. Actually, there's a y-intercept at 1, so maybe like that. Who knows? The point is that at x equals 2, say it's over here. There's a tangent line. There's my tangent line. I want to know what the gradient is. Okay? How do we find the gradient at x equals 2? What's the first thing you got to do? Can I please have? We're going to start off with, let's go with Luke. Example 4, so you got an equation. Part A, I want to find the gradient of a tangent line that touches at x equals 2. How would you start off? What would you do? Find the derivative first. All right, cool. 6x minus 5, again using power rule for those who weren't sure. Derive x squared, bring the 2 down, and the minus 2 by 1. So that's how Luke got 6x minus 5, so power rule. So use power rule to differentiate. So last lesson, I taught you the power rule or showed you the power rule. Derive each one. You should get 6x minus 5. Great. But I need to find the gradient at x equals 2. So he's found the derivative, which finds the gradient function. How do I find the gradient? Let's go with Charlie. So we found the derivative. Great. But how do I find the gradient at x equals 2? Beautiful. So at x equals 2, remember this tells you the gradient. The derivative tells you the gradient. So you just simply sub in 2 into the derivative function. 12 minus 5, you get 7. So that tells me this straight line equation is y equals, now instead of mx plus c, I now found m. This actually represents the value of m. It's the gradient. So you now know it's 7x. You just don't know what c is. Okay, and the next chapter, you then find c. That's called finding tangent lines and normal lines. Yeah. So that's the only extra step. But for this exercise, you're just finding the gradient. Cool. So part A was easy. What about part B? Part B says now find the angle that the tangent line makes with a positive direction of the x-axis. So what that's asking is, if this is your tangent line and your positive x-axis is over here, what is the angle that this makes? That's what it's asking. But we already know a fact. If this is your line, which is like your hypotenuse, and the horizontal x-axis like this is the theta angle that you're trying to find, you already know the gradient. Gradient was 7. And based on the fact that we just knew m is equal to, the gradient is equal to 10 of your angle. You know m. M is 7. So really, you're just asking 10 of what angle equals to 7. And to solve for theta, simply do the inverse of 10 on both sides. And whatever that says on your calculator, that is going to be your angle. Okay? So just make sure that you're in the right mode and you're converting it into degrees, then you'll know the actual angle. Anyone got a CAS ready available?
81.
It's 81.8, is it? Just see. Trig. Oop. Whoops, I didn't change it to degrees. There we go. Oh, there we go. 81.86 degrees. Cuckoo. Did it say to 2 decimal places? All right, so 87. So therefore, 1.87. Cool. You can have a go with the next question. That's example 5. I'll leave that for you, but the answer's already up on OneNote if you want to have a look, but that's just an example for you to try. Flip over the page. Okay, exercise 9B, question 16. Let's see how much of this you remember. So they've given you a graph, and they're asking, find the domain, so x means the domain, find the domain where the derivative is greater than 0. So that's your function. Find when will you have a gradient that is positive. Which x values will have a positive gradient? Let's go with Samar. Where do you think on this graph you would have a positive gradient? Remember, it's a gradient of a tangent line. So if you have to draw these tangent lines around this graph, where do you think we'll have a positive gradient? Not sure. Let's go with Aryan. Okay. For what, Charlie?
I'm not 100% sure, but would it be from negative a quarter to 2, non-inclusive of union to infinity?
Yes, that is correct. So, for those who aren't sure how to do this, remember gradients, you're thinking about the gradient. So, that's a gradient, right? But there are 4 types of gradients. You have a positive gradient, negative gradient, a flat line is 0 gradient, and a vertical line is undefined. So when you pick a point on the graph, imagine drawing a tangent, which means touches the curve. Every time you draw it, this is going to clearly have to touch on the surface, and that type of gradient is clearly a negative. So this is all negative gradient, negative, 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 until you reach the bottom. That has to be a 0 gradient. But then afterwards, to draw a tangent, a straight line that touches the curve, touches the curve. What we don't know, though, is at this point at 2, is that an inflection point? Or whether it's getting close to 0 and it carries on. So that's one part that I don't think it actually defined for us, so we're not 100% sure. It should have. And then afterwards, we can see it's still positive. All of these are positive. So if we had to answer the question, when is the gradient positive? It's clearly from negative a quarter to infinity, but it's just a question of whether that point there is an inflection point. I'm not sure. So because they haven't defined it, I would probably just assume it's not an inflection point unless they state so. So therefore, I would say x is from negative a quarter to positive infinity for a positive gradient. Okay, and then the next one is less than 0. Then it's the other direction. It's from negative a quarter all the way to negative infinity. B is x is an element of negative infinity up to negative quarter. Notice I'm not including the negative quarter because right at negative a quarter, the gradient's 0. Okay, that's clearly a minimum point, and then it changes direction. And then finally, C seems like it's only when x equals to negative a quarter. We're not 100% sure about the 2. Okay. Usually in your textbook, they usually draw an arrow and they tell you if it's an inflection point or not. Okay. If it is, then you include it. If they don't say it, don't assume it. Okay. All right. And then finally, the last one. This is now just a bit of problem solving. So you do this section of 9C once you've done your power rule, once you have worked a bit with your angles and can read a bit of gradients from the graph, then we do a bit of problem solving. So this used to be typical in exam 1, probably question 4 or 5. I haven't seen too many of it, but now of recent. But in the past, it used to be a very common one to come up with. So here we go. The gradient of the curve y equals a over x plus bx squared at the point 3, 6 is 7. Big line, but they're just saying gradient is 7. So m equals 7 at x equals 3. That's what I'm taking out of it. So I can see that at x equals 3, I know there's a y value there, but really it's just saying at x equals 3, gradient is equal to 7. But how do you find the gradient? We know the gradient is just the derivative, so delta y delta x must equal to 7. What is delta y delta x though? Here we go. Let's find the derivative of a over x and bx squared. Let's see if you can find the derivative with parameters. First one's easy. This bit is easy. The derivative of bx squared is what? Can I please have? Let's go with Una. Una, we've got 2 terms here. If I want you to derive bx squared, how do we derive bx squared? It's okay not to be sure. Not sure? Jason?
It's just 2b.
Very good. So yesterday's lesson with the power rule. This is your power. So that's a power function. The power rule from yesterday was bring the power down and then times by the coefficient. So in this case, it'll be 2 times b. That's the coefficient. And then minus the power by 1. Okay, so in this case, it would end up being 2b because 2 minus 1 is just 1. Also 2b, 2bx. Okay? Now, the second one is a bit trickier because it's got a fraction in it. But how would you go about doing the fraction one first? How would you do it? Let's go with Adonis. How would we solve or derive a over x? Beautiful. So rewrite this instead as ax to the power of -1. Okay, then it's a lot more similar to the bx squared. So now you can use the power rule again. Power is -1. So here we go, -1 at the front, times the coefficient, which is a, and minus the power by 1. So it becomes minus 1 minus 1. So if you write it out, that should be now -a times x -2. Or if you write it properly, delta y delta x should equal to -a on x squared plus 2bx. Okay, so that's my derivative. And I know the derivative is equal to 7. So let's rewrite that again. So we now have -a over x squared plus 2bx. That's meant to equal to 7, so that gives us one equation. So we now have 7 is equal to -a over x squared plus 2bx. That's one equation. Q. Now, why was this in the exam back in the past? Because the second equation is what students struggle to find. Where's the other hint? Because they've only given us one single line, but in that one single line, they've technically given us 2 pieces of information to then get 2 equations. Most students get that first one, if they know how to derive. You only get 1. Where's my second one coming from? I'm going to get my second equation because you have to do simultaneous equations to solve for A and B. You've got 2 unknowns there, so you need a second equation. No. Oh, can you? Sub 3. No, actually, yes, you're right. If you sub x equals 3, yeah, well, I meant to sub x equals 3, but it will still have A and B there, though. Yeah, so you're right. I was meant to put 3 in. I forgot to put 3 in. That's true. I'll just write it here so you remember. Sorry, I forgot to put 3 here and 3 there, but still I'll end up with one equation only, it would have been negative a over 9 plus 6b. That's still one equation. Where is my second equation coming from? Jason.
Well, you just put 3 and 6 into the...
This is what students tend to miss. So they get used to finding gradient is derivative, but in that equation itself, I already said x equals 3, y equals 6. This is the equation when x is 3, y is 6, and again, I get another equation with a and b's there. And that's why they used to put that in the exam a bit more often, because students miss out on that second bit there. So the second bit is sub 3, 6 into the equation, and you should get 6 is equal to a over 3 plus b times 9, because it's 3 squared. And we simplify that, that becomes 6 equals a over 3 plus 9b, and that's your second equation. Okay, and that was the only bit that I find that students generally miss. And then once you get those two, it's just now back to your algebra. How good is your algebra to solve that? Can you solve it when there's fractions? I usually get rid of the fractions, so I times everything by the denominator, and then I just work simultaneous equations. So for me, I would do this. Where's my green? There we go. I would say times this by 9, times this by 9, times this by 9, just to get rid of the denominator. And so my equation 1 should be then 63 equals negative a plus 54b. And I prefer that, okay, as my equation 1. And then same thing with this one, times this by 3, times this by 3, times this by 3. And I should get 18 is equal to, the 3's cancel out, a plus 27b. And that, to me, just back to year 9 mathematics again. Either you do elimination method or substitution method, up to you. I prefer elimination. So equation 1, equation 2. If I add the two together, so negative a plus a will cancel out. So equation 1 plus equation 2, these will cancel out. 63 plus 18, what's that? 11, 1, 7, 81 is equal to 54 plus 27b. What's that? 11 plus 1, that's 6, 81b. So it turns out 81 equals 81b, and therefore b equals 1. Well, that's nice. And then if b equals 1, you can sub it back in to find a. Okay? All right, I'll stop it there, but hopefully you can see how we took some of the derivative skills and then the function skills that we know to solve a problem. That's 9A to 9C. Okay, first thing you have to learn is your power rule. First principle is good for theory, then applying, get to C. Yeah? E, we're going to learn more derivative rules, so like chain rule and all the other 7 rules that you need to know. So right now, just start with 9ABC. That should give you a good sense of the derivatives. Okay? All right, I'll stop there.